Hello everyone and welcome to chapter 1. We are talking all about ratios and proportions for this chapter. And we start off with rates. So first of all, let's define what a rate is. A rate is a ratio, which is just a fancy word to say we write it as a fraction, that compares two different types of numbers. Okay, so for example, there's lots of rates that I'm sure that you're familiar with. Things such as, I'm sure you've heard of, like miles. Whew, my handwriting's crazy today. Miles per hour. So we're comparing miles and hours, or dollars per gallon, or dollars per ounce if you're comparing stuff at the grocery store. That's a great way to figure out what the best value is. Okay, so a rate is just a ratio or a fraction that compares two different types of numbers. Some other ones are like our heart rate, right? You've heard that before. That's how many beats your heart beats in a minute. Heart rate. See? Right there. Okay, a unit rate are really what are super useful for us. Okay, a unit rate is a ratio comparing some number with one of something else. Okay, so again, a unit ratio, a unit rate is a ratio comparing some number with one of something else. And that's really our most useful information. Really what this means is we want to basically do the division of the fraction. We usually want to turn the bottom number into 1. So for example, a problem that you would see like this is something like they'll say 24 miles in 4 hours. Okay, and we want to know what our unit rate is, or how many miles do we go in 1 hour. And so we would write this as a ratio or as a fraction, and usually you write it in order, or if it's asking, if it says miles per hour, that miles per hour. Miles goes on top, hours goes on the bottom. So miles, 24 miles over 4 hours. Okay, now we want to have our bottom number, we want to turn that into 1. So we're going to divide. Basically, we're doing the division, or dividing both the top and the bottom by the bottom number, which is 4. 24 divided by 4 is 6. So 6 miles in every 1 hour. Okay, or we would write that 6 miles per hour, like that. Per is that dividing line. When you hear the word per, think of the dividing line. Okay, let's practice another example of calculating a unit rate. So let's say we worked for 6 hours and we got $300. I want to know how much I make per hour. Per hour, per meaning we want hour to be on the bottom. So I worked for 6 hours. That goes on the bottom. And I made $300. Okay, so I need to do the division, or divide the top and the bottom by 6. 6 goes into 30 5 times with the 0 left over. So, and then 6 divided by 6 is 1 hour. So that means I make $50 per hour. Okay, another example. Now, this is another driving one. This time, I want to know what my miles per gallon are in my car. So that's how far I can go on 1 gallon of gas, which once you start having a car and having to pay for your own gas, you will start paying attention to. So let's say I drove 220 miles and that used 8 gallons of gas. Okay. So again, because I wanted to know miles per gallon, that's why the miles are on top, per is the divide line, gallons on the bottom. And now to turn it into a unit rate, we are going to divide the top and the bottom by the bottom number. So divide by 8, divide by 8. And you're welcome to use a calculator to do that. 220 divided by 8 is 27.5 miles over 1 gallon. Or we go 27.5 miles on 1 gallon of gas. That's your average, okay? So again, this per thing is really useful when working on these problems. That helps you to know what number to put on the top and what number to put on the bottom. So story problems, I mean, it's the same idea. It says, this one says, find the unit price of these juices. There's juice boxes. If it costs $2 for 8 juice boxes. Okay, so we've got $2 and we've got 8 juice boxes. Now, does it make sense to, which one does it make sense to turn into one? Does it make sense to find out how many boxes we can get for $1 or how much it costs for each box? I think it makes more sense to find out how much it costs for each box. So I want to put the box on the bottom. So I'm going to have $2 on top and $8 or 8 boxes on the bottom. And we're just going to do the same thing. Divide by the bottom number, divide by 8, divide by 8. And the bottom will be 1. So for 1 box, 2 divided by 8 is a quarter, or $0.25. Okay, so each box costs 25 cents. And if you're answering a story problem, you can say it that way. Each box costs 25. You can put 25 cents if you want, or you can do 0.25. Either way, it gets you there. Okay. Here's another story problem situation. I'm going to make a little chart. And we're going to have some cat food bag options. I'm making it cat food because I have 2 cats and I like cats. So you can buy different sizes of bags of cat food. There's a 40-pound bag, there's a 20-pound bag, and there's an 8-pound bag. Okay, now the world has kind of taught us that the bigger package we get, the better value. But now that that's well established, they like to mess with you. And so to find out the best value, you want to find the unit price. So for the 40-pound bag, it's $49. Wow, I don't know why I put a decimal there. That's fine, $49. For the 20-pound bag, it is $23.44. And for the 8-pound bag, it is $9.88. Okay? So to find out which bag is the best value, that means it's going to have the lowest. So we'll write this down. Best value is lowest unit rate. Okay? So we have to calculate the unit rates of all 3 of these. Now, does it make sense to find out how much it costs per pound or how much poundage we can get for $1? Normally, it's price per pound, which means we want to put the price. I'm going to write this price. We want price per pound. That makes sense to me. So we're going to put the price on top. So I'm going to make 3 fractions. I'll just put them down here. So we're going to have 49 over 40. We're going to have, oh, almost switched it, 23. That works out okay. 44 over 20. And then 988 over 8. And then, again, literally just do this division. So put in your calculator, 49 divided by 40, and you get $1.23. So that one's for every 1 pound. Okay, if we do the division here, we end up with $1.17 for every 1 pound. And then this one, the last one, is $1.24 for every 1 pound. So we want to find the lowest unit rate. So $1.23, $1.17, $1.24, lowest unit rate, which means the best value is going to be the 20-pound bag. Welcome to being an adult, friends. It's having to do things like calculate what the lowest unit rate is so that you can be effective with your money. Okay, another place they like to do this, we're going to talk about peanut butter. So, I'm just going to show you, there's a chart. I am doing these problems right out of the book. So we're going to use these prices for peanut butter. And again, we want to find out the best value. Which one can we get? Yeah, the best value, which means the lowest unit rate. So again, unit rate is price per pound. So we're going to do the price over the pound, and I'm going to write out all 4 fractions we're going to need for this. So nutty is going to be $2.19 for, oh, it's not pounds, it's ounces, sorry. And then the next one is grandma's, and that one is $2.79 for 18 ounces. And B's is $4.69 over 28 ounces. And the last one is Save a Lot, or Sal. And that one is $6.60 over 40. Okay, and then we put each one of those into the calculator, and the nutty is 0.18 cents per ounce. Grandma's is 0.16 cents per ounce, or dollars per ounce, I guess. This one is 0.17, and this one is also 0.17 per ounce. And so the low, I mean, they're pretty close, but the lowest is grandma's. So that's the best value. All right, so that's the basic idea of rates and calculating unit rates. Good luck.